Hello guys, I've turned on recording for this meet. So hopefully you have no problems being recorded. Mm, the discretion of turning on your video or microphone is totally up to you. If you have any questions, you can ask me. Otherwise, we can continue without them. We'll wait for a few more people to join in, then we'll start off. You can share the link with your friends and peers if they want to learn about load balancing too. All right, I guess we can start off. Hey guys, my name is Sabyasachi. I'm going to teach you about load balancing and using Azure Virtual Machines and Azure Load Balancer for setting up your application. So let's get started with it. I'm Sabyasachi. I'm a Gold Microsoft Student Ambassador. I've been an ambassador for almost 3 years now. I'm a 4 times Microsoft Azure certified cloud specialist. And you can reach me at sabyasachi.seal@studentambassadors.com. Well, this is what we are going to talk about today. We are going to talk about load balancing applications using Azure Load Balancer and Azure Virtual Machines. So there are a few things that we are going to go over. These are a few of those things. Firstly, we are going to learn what is load balancing. Then we are going to learn about why do we use load balancing, also how do we use load balancing, and how do load balancers work internally or externally. So let's get started with it. So what is a load balancer? As it sounds, a load balancer is something that balances a load. So the main use of a load balancer is basically to help different machines spread their load across different applications. So for example, let's say you have an application and you want to use a load balancer to divert the usage or the traffic of that application to different machines. A load balancer would help you do that. Now, in a very simple way, I can explain load balancing as a process of distributing incoming network traffics across multiple servers. So definitions are not really my thing, but there are something very important here. Distribution of incoming traffic across multiple servers or resources to ensure no single component is overwhelmed, thereby enhancing reliability and maximum performance. Very bookish definition, but what it actually means is that it basically divides the load among different servers or resources so that one server or one resource is not having to take the load of all the traffic. For example, suppose you have two people, right? Let's say you have two people, you have person A and you have person B, right? What you are supposed to do is divide one task among these two people. So let's say you give the task totally to person A. Would that work? That would be an extremely bad case. If you give that to person B, would that work? That would be an extremely bad case, because in either of these situations, either one of the person is having to take the whole load. What you can do is divide the load in between, give one to person A, give one to person B. So what did I just do? I did a load balances. Now, the first question that might come into your mind is, why do we use a load balancer? Well, of course, to divide the load, but that's a very small task, right? I can have different servers doing different parts of the job. Then why am I trying to have one job and then divide it into different things? Well, the thing is, in today's day, imagine dividing one single task into many tasks. Suppose you have 50 people and your task is to make a registration form. How many times will you divide that registration form? It's better to have one form and then post that on all the machines and then put a load balancer. In the other way, what we would do, we would basically have different parts of the registration inside different machines, which is a very tiresome process for both the developer and also the user. So our load balancer, often in DevOps terms, we mention load balancer as LB. So it ensures availability, reliability, and optimal performance of applications. Right? Why? Because it's always available to us, because if one machine goes down, there is another. Why reliability? Because if suddenly the number of users increase, there is no problem. And why optimal performance? It's because the number of users will not define how our website is performing. If there are more number of users, then good. If there are less number of users, then it is load balanced across different machines, right? So what does it do? It has efficient traffic distribution and resource utilization, right? So let's say load balancing. It has many different types. I just told you what is load balancing, right? But there are many different types of load balancing. First is public load balancing. Let's say what is public load balancing? It means that our endpoint, whatever we have, let's say this is our endpoint. Suppose let's say this is uh, gcd.com, right? Let's say this is gcd.com. There are multiple machines. And these multiple machines have one load balancer, and then this machine is like this load balancer is distributing traffic across these machines. So this is public load balancing. So you might say everything is happening internally. Why am I having? Why am I calling this public load balance? The reason is because you are getting a public link. The load balancer itself has a link. This gcd.com IP is not the IP of any of these machines, right? So where is it used? It's used for high traffic applications. Why? Because when I am hitting one endpoint, and then that endpoint is deciding where to go, that's the best way of actually load balancing. So you see, you have public facing APIs, which I just said are gcd.com or maybe whichever IP. This should be public facing IP also. Content delivery networks, as you know, content delivery networks are basically the ones that give us the data or whichever content that we want to access. It basically decides that hey, it will get to us really, really fast. Multi-tier web architectures. So let's suppose you are having a website which is having multiple tiers. For example, registration page, something on top of that, something on top of that. So if it's such a case, then public load balancing is your best way to go. And yeah, global application distribution, just because this is an IP, it's an actual endpoint. That's why having global applications is better. This brings us to the second way of load balancing. What is our second way of load balancing? It is internal load balancing. So why do we have internal load balancing? Let's see what is internal load balancing. In this case, you have multiple machines like this. The primary request will always go to one machine. And then this machine, there are some checks on this machine. So check that to which one should it go. So here, suppose the backend is already exposed. Backend is always exposed. That's why this is internal, because the load balancing itself is happening internally of a machine. It's happening internally when we hit the endpoint of the actual machine where the app is hosted. So where is it used? It's used within backend services within a VNet. VNet means a virtual network. It's used in database clusters. So if you don't know, let's say database clusters are a set of databases together. You can say that it's mainly used in the cloud for having multiple databases having the same configuration. So let's say I want a database that has 20 GB across, or let's say I want a cluster that has 20 GB across, but that 20 GB is shared between multiple databases. That's how internal load balancing will come into play. So again, you have internal APIs. So imagine this gcd.com using this API. If one of these machines are the head of this machine, then whatever load balancing is here will actually be ending up as the front end to this website. Sorry, as the back end to this website. So that is why load balancing is so important internally. Right. So I said that this is communication between virtual machines, since this is a machine, this is a machine, this is a machine. So they all connect virtually and then understand that who has the most resources, who wants to use what. It works like that. And the most important part of internal load balancers and why it is used is because of private application access. Since our application itself is running totally internally, the thing is, there is no chance of data leakage or anything of that sort, because our application has internal load balancing. The decision of which machine is doing what is always made internally inside the machine, and it is not made at the level of the load balancer. That brings to our third point, third type of load balancing, that is hybrid load balancing. So hybrid load balancing is kind of the middle way between both. I wouldn't say it's half of this and half of that. I would say it's 100% of this and 100% of that. But in together, it works as a different way, and that is hybrid. That is why we even have this. Azure has hybrid load balancing also. I'll show you a diagram in the next picture so that it's even clearer to you what is hybrid load balancing and how it is used. So why is hybrid load balancing used? It is used for on-premises to cloud migration, right? Multi-site application deployments. If you have multiple sites and you want to load balance them all, remember these two situations of load balancing were only for one site. But in our case, we have multiple sites itself. That is why we opt for hybrid. Suppose we want to load balance some sites among each other, then we want to load balance those whole clusters of sites together. That's why hybrid is important. And this is also very important, secure communication channels, because The thing is that communication is something that has to involve two or more parties. You cannot have communication between one person and one person. Like you need to have at least two people for communication. That is why you need to have extreme security when you're having load balancing across communication channels. The reason of doing this is because if you don't have secure communication with load balancing, a person X who's maybe on a other channel can listen to your stuff that you're talking with some other person. So it's extremely important to follow the hybrid model when we go for communication. That being said, I would like to show you the Azure load balancer. In this case, we would go over that what is the load balancer, what is Azure load balancer. We would also see some Azure features, and we would also see a hands-on making and deploying a load balancer, right? So coming to the point, what is the Azure load balancer? Azure load balancer is what? It's a highly available and scalable layer load balancer service provided by Microsoft Azure. So what is highly available and scalable? I'll explain to you in a very short way. Available means that my service is always available at all times. Seems straightforward, but what it really means is that suppose I want to access my service with 100,000 requests all of a sudden, that will work. That's highly available. I want to access my service when I'm not in my country from another location with hundreds of requests. That is possible, then I will call my site highly available. Let's say, uh, what is not highly available? Let's say my site is only present in India. Then I would say it is available inside India. It's not highly available. Right. So in this case, availability is basically the metric which tells you that how easily accessible and readily accessible your app or website is. What is scalability? Scalability is basically the way we scale some things up and down. So let's take an example, right? Let's take an example. In our case, let's say there was a website which has a load of 10 people on weekends and 100 people on weekdays. Let's say it is a IT website which has 10 people on weekends and 100 people on weekdays. So in our case, this website will basically have to adjust for those extra 90 people that are accessing it during the weekdays. But should I pay for 100 people during the weekends also? No, right? I should pay for 100 people during the weekdays and 10 people during the weekends. That is known as scalability. Why? I'm scaling up and scaling down. How easily can I increase the performance of my website and decrease the performance of my website as required? So that is scalability. So you might ask that, so why do we use the load balancer provided by Azure? I have the picture of how Azure load balancing works. So this will actually give you a good reason why this load balancer is so good at what it does. I also have some features to show you in a later slide, but yeah, we can start off with this one. So as you see, if you check out this place, if you check out just this part, what does it look like? Looks like a looks like a public load balancer. Why? Because as I showed you, this is some website. This is being accessed. This is a load balancer, and these are some machines. So the load balancer is deciding which one should go to which one, right? In the same time, check out this part. What is happening? Machines are being load balanced. So there's an internal load balancer and these VMs are being load balanced among each another. How is that happening? Basically, whenever this gives a request to public load balancer, this says that, hey, I want these requests to be served. Now this VM is running something, this VM is running something, this VM is running something. But these VMs are also connected to an internal load balancer. So according to their usage and metric, these internal load balancer might forward their own port. They might forward their own port to these ones, and then the request that was supposed to come here will actually come here and then go all the way through to the user. It might be a lot of lines and it might be a bit messy, but this is basically the way we try to achieve load balancing internally and externally both. I mean public and internal load balancers working together. You might ask me, what is the benefit here? The benefit is, imagine a full stack website, right? In case of a full stack website, you would basically have different front end and back end ports with different situations where suppose your backend is running on a different port, your front end is running on a different port, and you want to load balance your front end and backend independently. The number of people accessing your front end might not be equal to the number of people accessing your backend. Can be. Some people are doing very heavy tasks that are requiring the backend. Some people are doing very light tasks that are just handled by the front end. In that case, your hybrid load balancer will come a lot into play. It will decide which one to load balance, how much to scale, and everything. So the headache that you have to take as a user is least when you come to Microsoft Azure for load balancer service. So this part I've been wanting to talk about a lot. So what are the features of Azure Load Balancer? Let's say first there are health probes, right? I will talk about each of them in 1 or 2 lines. Then I have another slide where I will go and teach you about what are health probes, why is it required, and all about the other features too. So let's say health probes. Health probes are basically situations or small pieces of application, or you might say those are listeners that basically see that if the health of your application or your machine is okay. If it is okay, then it doesn't go on and then scale your application or we load balance it with another machine. When it is not okay and it has seen that your machine is under load, your application is not performing optimally, that time your load balancer comes and says that, hey, we have to add some new things. Who tells it to add the new machines and applications? That is the health pro. NAT rules are basically network address translation rules. These basically tell that which IP should be mapped to which port should go to which port. These are port forwarding and networking part that is very intricately configurable inside Azure Load Balancer. But even if you don't have the knowledge or you don't want to spend time on doing NAT rules, then Azure provides some basic NAT rules itself, and it will decide the best NAT rules according to your requirement. Outbound connections are basically connections that go from your application to some different server, right? So it can decide which machine should send the outbound connection. Normally, we only see CPU and memory as metrics. But in real life scenarios, CPU metrics also have some different things. There can be IO usage, there can be network usage and other stuff, right? So it's best to have all of them sorted with outbound connections. Session persistent basically means that my machine is going to have a session where It stores what sort of configurations I had made, and it can make new configurations according to that. Well, coming to the next one, it is traffic distribution algorithms. So let's say, what is traffic distribution? We talked about load balancers in the past, and load balancers are basically things that distribute traffic. So they distribute traffic on a base of certain rules and regulations, right? So traffic distribution algorithms are those basic rules and regulations. We can set them according to our need, and whenever required, we use them or maybe edit them. So we have a few features of health probes here. So we have continuous monitoring of backend resources. So it says it continuously checks if the backend resources are working or not, if that is the correct way of going by. It detects and remove unhealthy instances. If an instance is not working properly, if a machine is not working properly, it can detect and remove that. It can be configurable probe instance and thresholds. So basically, how at what interval your health probes check about the health of the machine, that is also configurable. Let's talk about NAT rules. NAT is network address translation, I told you. So it controls the inbound traffic redirection, as it says here. Supports port forwarding and translation. I told you about port forwarding. That is that if this port is not working with this IP, we can forward that port to some different IP and port. Translation means basically one IP and port translates to a different one, right? So if I go to google.com, that is a domain name server. That domain name server is actually connected to something different, right? It's connected to an IP. Now that IP itself is a load balancer, and it's facilitates secure communication to the backend services. We have outbound connections. Inbound NAT rules and outbound connections are almost opposites. It load balances outbound traffic from VMs, as I told you, provides source network address translation, which means that if my source is something and the request came from another endpoint, then it will translate that source to some different network translation. Let's say there are three machines, A, B, and C. B and C were load balanced. Now, when A requested B for something, B told C that, hey, you have to handle this. Now, when C comes back with the response, it can't give its own IP and own port because A had requested B. So it will say, with the help of source network address translation, that is SNAT, it will say that, hey, B, you have to pass this data up to A. That is how source address network translation works. And it optimizes connectivity for distributed applications. So there are a few more features like session persistence and traffic distribution algorithms, which I told you about in the past. So session persistence is basically maintaining client affinity for sticky sessions. It means that the session is in place and none of them are sent to trash. It ensures consistent user experience, which means that if I log in back again, I don't have to configure everything. And it has both source IP and session cookie based persistence, which means there are two types of storage, session and cookies. So it supports both. I told you about traffic distribution algorithms, what it is and how it works. So this is basically revolving around the same one. Offers multiple load balancing algorithms, includes default source IP affinity, least connections, allows customization based on application requirements. So I wouldn't go about explaining each of these in very intricate terms, but there are a lot of things that is important here. High availability, I told you about, it means that your website is always available. Scalability basically means that it can scale up and down depending upon how you use it. Performance optimization basically means that depending on how your website is performing, your load balancer might increase or decrease the number of machines, and it might reduce latency and increase response times by directing traffic to the nearest machine to your location. Cost efficiency, this is related to scalability a bit, because if you're only using suppose one machine worth of traffic, then it will only charge you for one machine. Simplified management, this is because the Azure load balancer comes with a lot of preset values. When I make the load balancer in front of you, you will see that I can make it in front of you in less than maybe even 30 minutes. That is because the load balancer itself has so many things built in and so many configurations already done for you that it's very easy to set up a load balancer as a first time user. And last, but maybe the most important, is secure communication. It facilitates secure communication between clients and backend services through built-in SSL termination and encryption capabilities. A big bookish term, but what it basically means is SSL, that is the thing that runs HTTPS, that is secure socket layer, that's SSL. So that thing is built into our Azure load balancer. This is a pricing. Azure load balancer for a regular student is usually very cheap. If you use a standard load balancer like me, for India region, I've given you these prices. So it's about 2 rupees an hour for the first 5 rules. If you have more rules than that, it's 0.8 rupees an hour. And for each GB processed, it's about 0.5 rupees an hour. Just give me 5 minutes, guys. I'll be back. Hey guys, I'm back. So for the gateway load balancer, we have a bit higher prices because it's actually load balancing your gateway itself. The price is about 1 rupees per hour. Actually, I meant to say that it's lower. And if it's a chain hour, that means it's like a set of hours together. Then it's $0.8. And the cost for the price, the data processor is also less here. So with that being said, let's make some load balances. I'll share my screen again. Let's discard and I'll share my entire screen. So I hope my screen is visible. So let's say I wanna do something like I wanna go to portal.azure.com, right? I'll make a load balancer. Let's create a load balancer. I'll select GitHub apps. I'll name this as test load balancer. Let's make an internal load balancer only for basic standard, whichever. So let's not do much configurations here. Let's do front-end IP configuration. Actually, before this, I will have to add a virtual machine because I want to load balance something, right? So I'll have to make a virtual machine first. Let's make a virtual machine. Let's include it in GitHub apps. Let's make it as test load balancer. Make it anything. Not selecting much here. I'll include it in test vnet. Management. Okay. These things are not really required unless and until you have to make some very intricate configuration changes. So you see, even for like a very good machine, I'm being charged only like 1 rupees an hour. So let's create this machine. I'll be downloading the private key and creating the resource. Yeah, got the key. Now I'll make a load balancer. Include in GitHub apps. Let's name it something like test load balancer. Let's make it internal. Let's make some front-end IP configurations. Let's name everything test. So it's test config. Virtual network, for virtual network, you'll have to select the same one that you selected for your machine. I'm selecting test vnet. Subnet is this one. And zone redundant. Okay. Adding that. So it's added. Let's go to backend pools. Let's make a backend pool. And you see, let's name this as test pool. And this is your backend address name. And this is your IP. And I name this as test LB. So that's your backend pool. So let's save that. So we have to add a load balancing rule and an inbound network address translation rule. So we already did talk about this in the past, but let's see. Let's make one. Let's name it test rule. These you should already have because you've selected. Let's just select port 80 for now and backend port 8000 for now. And let's save it. Oh, okay, we have to add a health probe, which I told you about. So these are health probes, which I told you. So health probes you'll have to use. Otherwise, it will not really work. Not sure why health probes are not showing up right now. Should. Right, showed up. Let's name it test probe. Let's go to some outbound rules. So outbound rules are not really available because it's for public load balancers and we have selected the internal load balancer. So that's why it's not there. But yeah. So tags you don't really have to add unless you need to. So we can review and create it. So our load balancer is created. It takes typically about 10-20 minutes. In my case, it did take 10-20 minutes for the last time because it was a very complex load balancer. But in this case, it's pretty simple one. So it shouldn't take much time. As you can see, it is deployed. If you go to resource, then you will basically see all the configuration for the load balancer. So since it is internal load balancer, you don't really have an external IP. Otherwise, here you should have something like an external IP also. Right. Now let's go back to our presentation. Okay. I'm starting off from the wrong slide. So this is the place where you can, this is the website from you can learn more about load balancers. And that was it for my slideshow. Do you have any questions regarding load balancers or anything? Anyone? Okay. Okay, no issues. So thank you everyone for this wonderful opportunity to teach you about load balancers. If you have any questions, you can reach out to me. There is also a quiz which will be sent to your registered mails. So make sure to drop off a message in the group once you're done with the quiz. I will send the quiz link in the chat group. Whoever scores the top points in the quiz in the shortest time gets LinkedIn vouchers or Xbox Premium, Xbox Gaming Pass. So thank you guys. Thank you.